The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and welcome to the fourth in the IA series of webinars on modernising energy efficiency through digitalisation. My name is Joe Ritchie. I'm one of the analysts in the Energy Efficiency Division here at the IEA, and I'll be moderating today's webinar, which is about light bulbs or cables, the role of digital energy efficiency in helping to manage electricity networks. Here's an overview of what the webinar today is going to involve. We'll first of all have an introduction from the head of the Energy Efficiency Division here at the IEA, Dr. Brian Motherway. And after that, we'll be handing over to our two speakers. We'll first of all have Charlie Edwards from Scottish and Southern Electricity Networks, and then we'll also have Angeliki Kalluri from UK Power Networks. After those presentations, we'll then be having a question and answer session at the end. So please feel free to send through your questions to us, and we'll try to get through as many of those as we can in the hour that we have for today's webinar. To send through a question, you can do so via the control panel on your screen. You can just click on the question box and write the questions in English, and they'll be sent through to us. And as I said, we'll try to get through as many of those in the hour today as we can. So now, to open today's webinar, I'm going to pass over to Dr. Brian Motherway, who is head of the Energy Efficiency Division here at the IEA.
Well, hello everybody, and thank you for joining us today. As Joe said, this is the fourth webinar in our series, Modernising Energy Efficiency Through Digitalisation. And I must say, since we started these webinars a few months ago, we're very pleased with the feedback and interest we've been getting from people all over the world to engage in this important conversation about how energy efficiency is changing due to the advent and deployment of digital technologies and all that goes with that in terms of making new ways of thinking about efficiency possible, but also creating some new challenges for regulators, businesses, and policymakers. And some of you may know that we've been exploring these issues most recently in our new Energy Efficiency Market Report, which we published just a couple of weeks ago. And in this market report, you may have seen that we have put a strong alarm signal, if you like, that efficiency progress globally is slowing down and that stronger policy action is required. And when governments come to explore what policy action they may take, the issue of digitalisation should, in our view, be at the forefront of their minds in terms of thinking about the kinds of policy options available to them and the kinds of issues they need to address. So in our market report, we explore how digitalisation seems to be changing energy efficiency, what opportunities it seems to be opening up, but also what risks and challenges it creates. And we developed for the first time the concept of policy readiness for digitalisation in relation to energy efficiency. So I'd encourage you to have a look at that report, which is available for free on our website. And we'd love to continue the conversation with you about anything you see there. For today, though, we're very lucky to have a couple of excellent speakers who are going to look at one particular aspect of efficiency. And for us, talking about networks today fits within the context that digitalisation is really shifting some parts, not all, but some parts of the efficiency conversation from the conventional look at end use of individual appliances as separate users of energy through, in the first instance, interconnectivity at the level of the home or the building or the factory, and then more and more to the level of the whole system. How devices and homes and buildings and local users and distributed resources on the supply and demand side all connect together into a systems thinking approach to the whole optimization of supply and demand at the level of the grid. And so today's speakers are going to explore that from a very practical and grounded level, and I hope you enjoy the discussion, and we look forward to getting your questions and comments afterwards.
Right. Thank you, Brian, for that introduction. So without any further delay, we're now going to pass the floor over to Charlie Edwards from Scottish and Southern Electricity Networks, who's going to give the first presentation of the day. We're just going to pass the floor over to Charlie.
Good afternoon, everybody. Can you hear me okay?
Yes, we can hear you, Charlie. The floor is yours.
Perfect, thank you. Okay, everybody. It looks like I've got this audience view stuck on the left-hand side of my screen, so I'll just try and get rid of that for everybody. Let's see how we get on with that. Okay, so my name's Charlie Edwards. I am a project manager at Scottish and Southern Electricity Networks. I work specifically in the innovation team. But before starting, just to give you a quick overview of who Scottish and Southern Electricity Networks are, we are the distribution network operator within the UK who operates all of the distribution level cables in central southern England and northern Scotland. So everything from transmission level, so about 132 kVA, down to your homes, that's what we look after. Okay, and the innovation team is interested in everything from electric vehicles to electrification of heat to community energy in the future and to energy efficiency, and how each one of these plays an important role in the jigsaw of the future, which is DSO, distribution system operation, as well as smart grid. Okay. So I'm not going to teach you to suck eggs. These graphs behind me are probably things that all of those on the call are very familiar with. Okay, the red line that you're seeing here, if you can distinct that from the orange line, is a typical 24-hour load profile on our network. And what you can see quite clearly is if I draw a black line on that graph, you've got a peak in network demand that is exceeding our capacity. Now, traditionally what we'd do, we'd shift that line up, we'd reinforce the network. However, these peaks are becoming more and more frequent. They're also growing in intensity with things like electric vehicles, more gadgets in people's homes, population growth, etc. And as a result, we need smarter ways of managing them, whether that be through peak reduction, time shifting, or an overall reduction in energy usage through something like energy efficiency. And that's what we've been exploring through a series of projects at SSEN. I've mentioned already something called DSO, or distribution system operator, distinct from distribution network operator. And it's this distribution system operator that we see ourselves moving towards in the future. Okay. In the past, distribution network operators, or DNOs, have very much been about getting electricity from A to B. It's been an engineering equation of making sure that the capacity on the network is there for the demand on the network. Distribution system operator is a lot more about balancing. Okay, it's about the enabling systems that are needed for us to have distributed generation, for us to have smart technologies, for us to be able to automate things in the way that we want to in a digitized world. Okay, so it's going to become a lot more commercial, a lot more economic. It needs IT considerations, and there's a lot more cross-vector to bring into it as well. And what I mean by that is not just DNOs working in isolation, but with transmission, with generation, with supply, with gas utilities and water utilities across the system. Okay, and that's what we're working towards in the innovation team. So I'm going to bring you into focus with two projects that we've been looking at around energy efficiency and how we as DNOs see we have a key role in energy efficiency. The first of which is at the low voltage level, which is sort of 33 kVA and down within the UK. So it tends to be your kind of substations that are supplying towns as opposed to your kind of grid level substations. Okay, the SAVE project is one project that we looked at that looked at the LV network. It was a £10 million Ofgem funded project, so funded by the regulator here in the UK. 8,000 customers across what we call the Solent area. So the Solent area you can see highlighted in grey on the map on the right hand side of the page. The yellow highlighting is SSEN Southern Patch. So a reasonable representative of the UK that we've got there, and it's the largest collection of field data in the UK, given the 8,000 customers, 4,000 of which we are monitoring at individual household level, which I'm going to show you in a minute, for over 3 years. Okay. The project looked to trial domestic demand side response, which we included energy efficiency within, and customer engagement, and it produced what we call a network investment tool, which I'll show you in just a little bit. So what was the project all about? Well, the project rolled out 4,000 what we call Navitas loop devices, very similar to a smart meter, apart from it gives you more granular data, so 10-second power data, across a representative sample of homes within Southampton. I mentioned 8,000 customers on the last page. That's because 4,000 customers were also monitored at network level, at feeder level, completely mutually exclusive to this. That was because of another trial within SAVE, which I'll just touch upon in a couple of slides as well. But the beauty of these Navitas loop devices were that in the UK, smart meters aren't rolled out by the DNO. And as a result, to get access to smart meter data, a DNO would need to partner with a supplier. Now, because SAVE was all about getting a robust sample, making sure that people are very much representative of the wider population, we didn't want to partner with any specific supplier because we wanted to make sure there was no early adopter effect in our trials, so that everything we did here could be scaled, not just across SSEN's patch, but across the UK as well. So we put a lot of work into making sure that our sample was robust. We ran what's called a randomized control trial to make sure that our results were statistically significant as well. So the randomized control trial meant that of our 4,000 households, 1,000 of them were instantly put into a control group. Nothing done to them at all. They purely provided a baseline for us to ease analysis and allow it to be as robust as possible. The other 3,000 customers that were then remaining, that were domestically monitored, were divided into 3 different trial groups where we test different initiatives on them. Okay, the reason that we chose about 1,000 customers is because given a 1,000-person trial group, you should then be able to statistically significantly detect any effect size from an intervention, whether that be energy efficiency or anything else, of above 6%. Otherwise, it starts to get lost within the kind of natural wobble, if you like, that you have within individuals' household profiles. Okay, so a lot of work there going into making sure this is a robust sample, and you can see some of the tests that we did. So of each one of those 1,000 customers that we recruited into each trial group, we tested how they matched the general population. So we did a survey with them, very much matched census survey data with a few more energy inclined questions in there. So we have all sorts of demographic information for each one of these households to understand how each household might match the wider population. And you can see from the graph on the left there, there's an example of how the income of the households on SAVE match the wider population. Okay, so SAVE's in red, general population's in blue, and you can see some similarities there that we've got. Likewise as well, we wanted to make sure we had no early adopter effect, so no particularly eco-inclined people on the project, again, so that our findings were replicable and not subject to this early adopter effect. And you can see there that SAVE is very much replicable in the kind of eco attitude of people on the project and the wider Southampton area. Okay, the methodology behind the SAVE trial then is that we trialled 4 different initiatives. I've mentioned 3 of those domestically monitored, the 4th of which is the one that was monitored at grid level, at feeder level, which I'll come on to in just a second. We had 3 different trial periods, which you can see behind me by the 3 pie charts. And what this allowed us to do is effectively develop an initiative, trial it over a 3-month or a 6-month winter period, amend it, trial it again, and then amend it again and trial it again. So this iterative approach to development allowed us to continually improve the way in which we rolled out domestic demand-side response. Okay, the 3 trials that were monitored by the 4,000 domestic monitors were energy efficiency, data-informed engagement or nudge-based techniques, and data-informed engagement and price signals. The trial that was monitored at feeder level, so substation level, network level, as opposed to individual household level, was called community energy coaching. This was a far more social trial than the other trials, less quantifiable in its outputs, and more about how dropping what we call a community coach into an area as a DNO can build up relationships with the local community, support the local community, but also in turn help them reduce their energy costs, help them reduce their energy consumption, and help identify fuel poor customers, those customers most in need, so that we could respond to them in outages. Okay, I'm not going to focus on that trial particularly today, but we do have a website, save-project.co.uk, for some of the more interesting kind of social aspects. Okay, the trial I'm going to focus on today is the energy efficiency trial and the network investment tool, just because it's a big project and we're limited on time. So energy efficiency trials on SAVE. So the first trial period with regards to energy efficiency, we sat around the drawing board and we said, what's the most cost-effective thing that a DNO can do to roll out energy efficiency to customers? What we can do is we can advertise the benefits of energy efficiency to our customer base, we can deploy some behavioural techniques, and we can discount energy efficient bulbs in this case to customers to see what the uptake was. So we rolled this out across 1,000 customers, and whilst of that 1,000 customers we saw a reasonable uptake level in terms of people visiting our website where they could find out more information, where they could procure bulbs. We had about 20% of 1,000 people visiting our webpage. 3 of 1,000 people bought bulbs, so uptake incredibly low. Meanwhile, the EnergyWise project, which Angeliki is going to talk to you about, had some very promising results with regards to energy efficiency. So it was back to the drawing board for us and make sure that we can draw upon the learning from our first trial period as well as from EnergyWise. What we look to do within our second trial period with regards to energy efficiency rollout, or LED bulb rollout in this case, was say, okay, we've trialed a reactive approach. What's now a proactive approach? What's the most engaging thing a DNO can do? So what we did is we wrote out to customers and we offered them the install of LED bulbs completely free of charge by the DNO and performed by the DNO. What we saw as a result of this was a 76% uptake in LED bulbs across our 1,000 customers. So about 760 of 1,000 customers uptaking bulbs, with an average of 49 watts load reduction per customer across the 1,000 customers. So that is across your population. That's not just the people who participated, that's across everyone. We got 49 watt load reduction at peak during the winter months. Now, 49 load reduction per household doesn't sound huge. However, when you account in the UK, the average load reduction between the peak hours of 4 till 8 o'clock in the winter period is about 500 to 600 watts. That's about 7 to 9% of peak demand, okay? Which if you take that to one of your network planners in a network operator, they'll bite your hand off, because that buys them a significant amount of capacity and potentially several years longer asset life on the network, okay? What it resulted in for customers: average saving of 90 kilowatt hours per year, 16 pounds per year. Given a 10 to 15 year LED lifespan, you can do the maths, but maybe 150 to 200 pounds of savings per customers out of rolling out these bulbs. And you can see there that if you were to scale this rollout, so if every DNO in the UK was to do this rollout, was to change over households to LED bulbs in the same way that we did in Save here, you could save the same amount of electricity as a nuclear power plant. Okay, which when you consider the cost of doing a Save replication LED rollout across the whole UK would be 1 billion, and a new nuclear plant would probably cost in the region of 5 billion, just highlights why we need to be looking at demand side measures, including energy efficiency, as actively as we're looking at generation measures, okay, because they are cost effective if done in the right way. Even better, the impact of this was 5% better on vulnerable households, okay? A big thing in the UK is looking at the social side of these measures, especially as we move towards a smart grid. How can vulnerable customers, how can the fuel poor keep up with the opportunities related to a smart grid? This is a big win, the fact that the impact of the LED interventions is even greater on vulnerable customers. Now, you'll probably say to me, Charlie, that all sounds very interesting. It sounds great. However, it sounds like a very costly way to engage customers. And you wouldn't be wrong there. It is a costly way of engaging customers. However, what we identified through the community trials is actually there's a huge amount of space for us to be working more smartly here with maybe the other utilities, gas utilities, water utilities, local councils, who all have an interest in water efficiency, gas safety, rolling out initiatives to customers. And as a result, what we've done off the back of this is we've created joint utility initiatives whereby you can take down the cost of customer engagement, and you can actually build quite attractive business models to roll out this energy efficiency very cheaply in a similar way to which we didn't Save. So how are we taking this data further forwards? Well, we're taking it further forwards into Save's network investment tool. Okay, so the network investment tool is effectively a series of models which allows the network planner to input all the data they have about their network. And at the other end, they will be told the most cost-effective way of managing their network, whether that be through an energy efficiency initiative, whether it be through additional reinforcement, or whether that be through some sort of other smart initiative. So you can see the value of all this data from Save now coming into play. The network investment tool is built up of 3 main models. Okay, the customer model was developed by the University of Southampton, and it used all of that brilliant data that we've gathered on Save from those 4,000 domestic properties, each of which we have a census survey for. And it said, okay, what is the demographic information that is most likely to affect the way in which people use their consumption? And as a result, how do different demographics use their consumption? Given we've got this information, and given we've got information from wider census information across the UK, we can then understand on almost a postcode by postcode basis what types of customers sit where on the network, and as a result, what their consumption profiles might look like. By dropping what we call a network model on top of this, which understands the postcodes where customers are attached to the network, we can then model consumption profiles for estimates of what different types of household will be consuming onto the network to get a more accurate view of what consumption on the network might look like than in the past. Okay, what we can then do very smartly is we can run a range of different future scenarios. Okay, so there's a lot of work going on in the UK with regards to what future scenarios look like, but we can run up to 4 future scenarios at once, which will tell us different levels of EV, PV, and heat pump growth. And as you can see here, I've run a future scenario that said there's going to be 3 EVs down this street and it's broken the network. What we then do is we layer on different initiatives, and we look at the cost of different initiatives, we look at the level of load reduction we need, and we look at how we can solve this problem. And what the pricing model very carefully does is it runs a load flow with 3 different strategies to understand, both moving forwards in time and working backwards in time up to 40 years into the future, what the most cost-effective way of managing your network is going to be. Is it going to be energy efficiency? Is it going to be price signals? Is it going to be a combination of the 2? Is it going to be smart? Is it going to be batteries? And it will give a network planner effectively a watch list of each one of their LV networks to understand when they're going to need to reinforce, what the cost of those reinforcements are going to be, and what measures are likely to be most cost effective. So whether energy efficiency comes into that equation. Okay, and that's how we're using a lot of the data that we can gather from these sort of projects. Quick illustration here of what outputs from the custom model start to look like. Okay, so what you can see here is how different demographics of customers based upon different what we've got called lower super output areas, so groups of about 1,000 customer based upon census information. Okay, and each polygon will represent how they respond to our LED intervention on safe. So you can see the darker colors suggest a higher level of load reduction of LED bulbs, up to 10%. Lighter color, lower levels of reduction through LED bulbs. LED bulbs, just an example. We can also do this with price signals, data-informed engagement, whatever else you like to look at. You can see quite clearly around the cities, level of load reduction is lower. Around London, over to the right-hand side there, you've got a lower level of load reduction because it's mainly flats, so smaller households, less light bulbs to change. But where this gets really nice is we can overlay this data with other forms of information. For example, where our most vulnerable households are, where our most fuel-poor households are. If we're doing some form of engagement in that area anyway to engage fuel-poor households to make sure that they're okay in power outages, we can start to understand whether it's cost-effective or whether it's going to be beneficial to roll out, say, LEDs as well. And here you can see in the 10 areas of our patch where we have the most vulnerable households, LEDs are looking like you get a pretty good response from them. As a result, you'd probably look at running this initiative. That shows how we might roll out energy efficiency of the low voltage. Very, very quickly, because I think I'm running slightly short on time, so I'll skim through this quick, guys. High voltage. The way in which at the moment we run energy efficiency markets at the high voltage is through what we call a constrained managed zone. It's basically a flexibility market where people tender in to provide us given levels of kilowatt or kilowatt hour load reduction at peak times in a geographically constrained area of the distribution network. If you're familiar with National Grid's STORE program, it's sort of like that, but geographically defined. Okay. Now, typically what we've seen on flexibility markets is that they are very much dominated by things like managed energy generation, commercial demand response, and battery storage. Things like energy efficiency and domestic demand side response have struggled to compete. What we learned through SAVE is that actually SMEs, local authorities, local housing associations, and community groups are probably those who are best placed to roll out things like energy efficiency. They've got the relationships in the local area, they know the local area best. However, they don't have the access to resources, the access to funding to understand how they can participate in flexibility markets. So we set up a project called Social Constrained Managed Zones, which looks to open 3 main barriers that we saw to these smaller organizations participating in flexibility markets so that they could provide energy efficiency to us as a solution. Those were breaking down visibility and complexity barriers, so effectively marketing better constrained managed zones and allowing people to understand it without having to trawl through pages and pages of legal documents. Okay, breaking down procurement barriers and payment mechanisms. Okay, so payment mechanisms in the past have been set up to be availability and utilization based. How can you pay a utilization payment to something like LED bulbs? It's always there, it's always available. So those mechanisms aren't set up right for energy efficiency, so we're fixing that. And social costs and benefits. Okay, there's obviously a lot of social benefits of rolling out energy efficiency, carbon reductions, engaging vulnerable customers, as opposed to something like diesel generation to manage the network. So how do we make sure that they're recognized as well, and how do we quantify that? What we've been doing is we've been doing it through this SCMZ project, Social Constrained Managed Zones, with project partners NEA and Navigant. We've done a series of community engagement. We've done matchmaking workshops to bring people in the community together so that they can stack benefits in the same way in which I mentioned that we might be able to with the gas, the water, the local council utilities earlier on. It's effectively stimulating the market so they can do this themselves, and then simplifying tender processes so that when we get to the tender, these organizations who are often resource constrained, often strapped for cash, can actually get a bit of a boost to their business case to allow them to build it through the consultant support or seed funding, allowing them to say, I want to run this energy efficiency initiative, but I have no idea what it means in terms of kilowatts, kilowatt hours, and as a result, pounds and pence to the grid. And what that seed funding or consultant support is there to do is effectively allow them to take that initiative into a into a commercial business case. Okay, so that they can then take their tender application forwards. We've currently got 2 tenders that we are taking forwards with regards to domestic demand side response to provide services directly to the network. That was a quick run through of the SAVE project and SSEN strategy to domestic demand side response. I'll look forward to your questions afterwards. I think Angelique's up next.
Great, thank you, Charlie. Thank you for that overview. And yes, as you mentioned there at the end, we will have some questions and answers after Angelique's presentation. So we've already had a couple come through, but please, as you have questions that come to mind, please feel free to send those through to us. We're now going to hear from Angelique, who's just taken over the screen. And Angelique, might just get you to put that on full screen so we have the slide on the view. We have 2 screens on. Let's see how we go here. Here we go. Okay. So Angelique, if you put the screen on, if you put the presentation back onto the full screen view, yep, and then under the 3 dots underneath the PowerPoint slide, and then go hide presenter view. Oh no, that didn't do that. Application manager. Okay. I mean, what we can do, Angelique, if you want, is we can just, if it works, we can just, yeah, as you're doing there, tailor the size of the screen to fit tailor the size of the presentation. Then we can just talk through that. I think that's okay. Yeah, it's fine. Okay. Angelique, we'll do it this way, and I'll pass over to you. The floor is yours for the second part of the presentation today. So I don't know if we have Angelique on speaker there. Angelique, are you on mute at the moment? One second, Harry.
Hello, can you hear me now?
Yes, we can hear you now, Angelique. Floor is yours.
Thank you. Thanks for the invitation today. My name is Angelique Kolouri, and I'm a project lead in UKPN Networks innovation team. So today I would like to talk to you about the work we are doing in the energy efficiency space. So I will start with a quick introduction about who we are, then talk you through our journey over the last decades, and focus on 2 strategic projects we have been working here in innovation, EnergyWise and Firefly. So just to begin about who we are, UKPN Networks owns, operates and manages 3 of the 14 regulated electricity networks in Great Britain. Our regulated networks are Eastern Power Networks, London and South East, which covers Kent, East Sussex and West Sussex. We deliver electricity to 18 million people and serving almost a third of the UK's population. We have over 9 gigawatts of distributed generation connected to our systems, serving a peak demand of 15 gigawatts. And we are committed to becoming the most innovative DNO in Great Britain. We do so because we believe that innovation is key to delivering best service and best value to our customers. And this is a primary influence for each element of our innovation strategy, which will ultimately deliver safer, more reliable and cost-efficient supply, network ready for low carbon technology and adoption, and future ready network. So over the past decade, we have been working in the field of energy efficiency. So our very first project in 2010 was Low Carbon London, an off-GEM funded project, which was the largest trial this time, testing low carbon technologies covering energy efficiency, heat pumps, electric vehicles. And the project laid the groundwork for UK Power Network's future trials and innovation projects. It didn't, however, target any specific customer groups or demographics. And one of the things that came up was that vulnerable and poor customers may not access benefits from smart technologies and potentially be left behind in the future. So this is why we set up EnergyWise project back in 2014, another off-GEM funded project, which I'll cover in the next minutes of my presentation. So this project was completed last year and is followed by a series of other trials testing domestic demand-side response, such as Urban Energy Club and Home Response, which are not covered today, and Firefly project focusing solely on energy efficiency, which kicked off earlier this summer and will go up until mid next year. So EnergyWise explored how residential customers who may be struggling with fuel bills can better manage their household energy usage and their bills by charging their electricity use. So the project recruited 550 households in Tower Hamlets and carried out 2 trials. So the first trial focused on energy saving, and the second trial focused on energy saving and demand-side response. So we formed a partnership with a range of stakeholders, including British Gas, the energy suppliers, social housing associations, and a trusted community partner, the Bromley by Bow Centre. I think if I do that, probably better. The project lasted for nearly 5 years, and yeah, we are also very pleased to receive the award of the Community Initiative of the Year from the Energy Institute only last week, which is great recognition for the project work. So upon signing up to the project, the participants received energy efficient devices such as LEDs and eco kettles and advice from a customer field officer team that we set up in the community center, and also smart meters. This was the first trial that basically explored the energy savings, so how much participants can save, knowing their electricity bill better and by using all these devices and advice. So the customer field officer team also had a free phone support line that was accessible by the participants and offered free support throughout the project. In the second trial, the participants were split according to their smart meter type. So the second trial tested energy savings and energy shifting. So those participants on a prepaid smart meter were offered a critical peak rebate. We call it bonus time, so which was a dynamic price signal, which was spread across weekdays, weekends, and afternoons, mostly targeting peak demand periods. So in a nutshell, in bonus time, for 1 unit of electricity that the participants saved, they got 10 units credited back to their smart meter. So basically, we encourage them to use less during the peak times. The other customer group, so those on credit meters, were offered a home energy free time of use tariff, which was a British Gas commercial tariff, and which was a static event. So basically, customers were offered free electricity during the weekends, Saturday or Sunday, depending on their choice. And in that case, we're prompting them to shift their demand away from weekday peaks and utilize more energy during the weekends. So one of the key successes for the project was customer engagement. We set up, as I said before, a customer field officer team in the Bromley by Bow Center. So this team had a unique knowledge of local culture and languages. They also understood the community. They were part of the community, and basically they delivered they became a trusted partner. So yeah, this resulted in having a tailored engagement strategy. The participants, you can see here some testimonials. The participants felt that they were part of a larger community, family. They had a very direct dialogue and engagement with the team, and that was really great because it resulted in great results, such as very high sign-up rates. For the first trial, we had around 40% sign-up rate, which was much more than what we were expecting. And in the second trial, we had 85% of sign-up rates, which was great. And we are very thankful for their support throughout the project. So I'm not going to go into a lot of these details here about the results. So just to take your attention, a couple of points. So in a nutshell, all these trials delivered very good outcomes in terms of reducing network peak demands, delivering benefits to the customers, and also understanding customer behavior. So the trials worked very well and delivered a lot of insights, qualitative and quantitative insights. Just a couple of things to draw your attention. So in the bonus time trial, we found that the availability of large flex loads, such as tunnel dryers, was key for participants to see an impact and benefit from the offer. Also, in the home energy free time, the weekend tariff, we found that there was indeed a reduction of 2.2% in the weekday peak demand, which was great, but there was also a 22.2% of increase in the peak demand during the free period. So if someone, another DNO or us, were to deploy this as a business as usual tariff, we need to be cautious about this potential new weekend peak load for secondary substation. So just to wrap up about energy-wise, these are our key takeaways from this project. So first of all, having different organizations from different backgrounds working together is very important to deliver tailored support services. As in our case was a community center, but also social housing associations, University College London, consultancies, energy suppliers. So it was a very diverse project and very, very innovative. And the second one was because as a DNO, we don't have the direct access to customers, and we don't know a lot about their behavior. Through this project, we had better understanding about the behavior, also demographics, customer needs, and type of households, type of energy consumption, and so on, through the qualitative insights and surveys that we did. We also found that engagement with vulnerable and fuel-poor customers is possible, but yes, Charlie mentioned before, sometimes it can be also costly. So we need to, especially if you require to design a tailored strategy, and we need to work with diverse groups, then we need to bear this in mind. And the last one is that indeed it's possible to deliver and unlock flexibility services from this particular customer segment. So it was good news for us. So while EnergyWise has tested the impact of energy efficiency on domestic customer demand, we found that there hasn't been any specific project looking at the DNO-led intervention and how DNOs can deliver a holistic approach of energy efficiency. So Firefly is the first project that is looking to trial this approach in the UK. So in a nutshell, the project is looking to understand the DNO-led approach, so how exactly DNOs can implement energy efficiency, and is doing that by an extensive exploration of global best practice. And we'll talk about this in a minute. And there is also a separate element around the regulatory impacts of that. So any changes that will be required to implement this solution if we identify that there is indeed a potential for DNOs to deliver energy efficiency. So the project is now phase 1. We call it phase 1 project, which will look at the feasibility and benefit assessment. So we'll come up with a detailed CBA, cost benefit analysis. And if it's successful and it shows that there is indeed a potential, then we can carry on with a phase 2, which will focus on trialing specific sites in our patches. So the project is looking to deliver a set of outputs, such as insights from selected utilities that we are going to interview as part of phase first task on global best practice analysis. Then it will also identify optimal measures for energy efficiency in the UK, cost and benefits of selected locations, and also inform essentially what is the role of the DNO in unlocking associated benefits. So yeah, we're very excited about this project. As you can see, we are now in the first months of the project. So it kicked off earlier this year, and we have started with the first task, which is the International Energy Efficiency Scan, which I will present in the next minute. And in the meantime, we are also doing an assessment of the energy efficiency potential in the UK. How we're doing that, we are dividing customers into different groups, and then looking at the different interventions. We're going to match each customer segment with a list of energy efficiency measures, and then looking at our data from primary, secondary stations and forecasts. We are going to come up with a modeling exercise, which will help us determine the potential. In the meantime, we also kicked off engagement with other DNOs, DNA, which is the Networks Association here in the UK, and BASE, and we are looking to engage with the regulator very soon. So this separate task is looking to determine what is needed, what are the requirements for, and essentially changes for energy efficiency in the next regulatory period, if we were to deliver, as DNO, were to deliver energy efficiency. And early next year, there's going to be a trial design. So assuming that we're going to go for phase 2, we're going to come up with a set of trial locations and strategy for what exactly we're going to test. So today, I just wanted to briefly, I'm conscious of time, briefly get your attention on some key best practices that we have identified as part of the first task. So I'm not going to go into a lot of detail here, but basically what we are doing is, by looking at the different examples across the globe, we want to understand the challenges, costs, what was the intervention, how it was organized, the procurement side of things, and what was the ultimate objective and what was delivered. So first example that you can see here in Con Edison's program, basically the objective was to defer $1 billion investment in a new substation in Brooklyn, Queens area, and it achieved 52 megawatts of peak load demand reduction, together with customer-side and utility-sided solutions such as energy efficiency, incentives and rebates, LED lighting, but also combining it with energy storage, fuel cells, and demand response. It went over and above, and however, it's considered a bit more expensive, but also very successful one in terms of deferring a huge investment. for a new substation. The second project was the Paget Sound Energies project on Bainbridge Island, which was had a lot of community involvement, and was backed by a lot of organizations, local organizations, and its main focus was to consume less, understand actually how much we consume, the island consumes, and also focus on educational programs, building an online platform to show real-time data. Yeah, the result was also very, very successful, considered as the key project. The third one was the European example that we identified in Switzerland. So it was backed by local government of Geneva, and it started more than 10 years ago. That one wasn't driven by network reinforcement, and so the idea was to support residents to reduce their energy consumption and carbon emissions, and it's focused again on education and delivered a lot of tailor-made action plans. And also financial loans. I delivered a lot of financial advice and support, and it has, to date, it has delivered over 200 gigawatt hours of savings, and created 400 jobs in sustainability, so it boosted the local economy. And the last one was, a combination of the other three, was put in place to replace retiring fossil fuel power plants, and this one is still ongoing, and includes also a combination of measures such as real-time energy consumption platform, distributed generation, and particularly renewables like solar PV, and also energy storage. So again, the idea is that we are going to look at all these best practices, understand key insights, the challenges and the problems that were faced, and also pick up those that they are more suitable for us, as you know, and then come up with a strategy for the different networks. So just to conclude, we understand that this is new territory for us, but we know there are a lot of learnings and challenges, and that's why we're here, we're doing this. So we believe that we need to unlock benefits from energy efficiency, because there are a lot of benefits to the DNOs, such as deferral, low related reinforcement, reduction of electrical losses, carbon reduction, societal benefits as well. But what we have seen at the moment is that energy efficiency should be considered in combination with other technologies, and also in terms of the CBA, there are lots of unknowns, so we need to be cautious of different variables such as cost of marketing, customer uptake, how customers are willing to adopt energy efficiency, and also the number of years of deferral will determine the value of energy efficiency. So we're talking about maybe a regulatory period of deferral, or maybe 10 years or more. That is going to play a big role in the CBA. But overall, we are very excited to be part of this project, and we definitely think that there's an opportunity to form our position as a DNO once we have all the evidence collected. So I think that's it from my side. Thank you very much for listening, and I look forward to the discussion.
Great, thank you very much, Angeliki. We'll just transfer the control back to us, and then we'll start with the Q&A session. Just a reminder again, for those that are interested, to please send through your questions. And for those that are interested and who have asked questions, yes, the webinar is being recorded, and all the slides and the presentations will be available after today's webinar. But to start off with potentially a broader question and a technology-based question here, and we'll start with this one for you, Charlie, is around the digital technologies that were really key in enabling the SAVE project to take place. What digital technologies did you see as being most important, and what methods did you use to roll those out to the consumers that were associated with the project?
Absolutely, Joe, I can take that one. Thank you. So within Save, I suppose the Navitas loop devices, so the monitoring devices we had, were absolutely key. Moving forwards, you'd suggest that that would be smart meter data. The value of that smart meter data to us here, especially if we're looking at things like energy efficiency, where the gains can be fairly marginal with certain techs of energy efficiency, and detecting them can be challenging given the sort of variability in your daily load profile and of an individual household. Using smart meter data with the level of granularity that it provides alongside the correct level of statistical rigor is going to be absolutely crucial to us. And I think going forwards, it's kind of a hand-in-hand thing. It's not just having this automation in place, it's also being able to understand it and use the statistics in the correct way. And I think that's something that's quite new to us as a DNO. And I think there's a big space around us making sure that what we're doing here is statistically robust when we're gathering this data, so that we can ensure that when we're deploying energy efficiency to run the network, we can continue to provide security of supply. Okay, because at the end of the day, the role of the DNO is getting electricity from A to B. And if we don't get the level of load reduction that's needed out of the energy efficiency that's given, you're putting at risk the security of supply. So there's a big piece there in making sure the monitoring is correct and make sure that you have the monitoring in place. As we move forwards with the sort of domestic demand side response, I think the whole system, the whole home automation piece becomes absolutely key. From our behaviour change trials that we ran, we didn't have any automation. The bid for Save went in 2011, I think. So a little bit probably before a lot of the automated tech that's now come out and is probably running the market was around. And I think there's a few more recent projects that will be looking at a little bit more of the sort of in-home automation, but especially when we get things like electric vehicles, that potential for in-home automation, controlling not just your vehicle, but your energy efficiency as well, maybe your heating as well, especially if that becomes electric, that becomes of interest to the DNO, is only going to amplify in terms of scale. To put it in perspective, we build the network at the moment for an average of about 3 kilowatt per household at peak time is what we assume. If you can imagine you put a 7k kilowatt EV on that, and then maybe an 8 kilowatt heat pump as well, suddenly that demand of the household at peak has gone from 3 kilowatt estimated to 3 kilowatts plus 7 plus 8, okay, maybe 18 kilowatts. Firstly, the potential for control there, if you're controlling 10% of that, goes from, well, maybe 300 watts to, let's say, 1.8 kilowatts, which is massive. And secondly, the potential for requirements there escalates massively. So I think it's a big area of focus for us going forwards. I don't think there's been a huge amount of tests in the DNO space at current with regards to entire home automation, but I think that's what's coming in the next round of NIC projects that you'll see out of Ofgem. But the smart meter data there within Save is absolutely crucial.
Great, thanks, Charlie. Angeliki, did you have anything to add around some of the enabling digital technologies?
Hi, yes, so I would agree with Charlie. The biggest challenge and opportunity for the DNOs is to understand better the data that are coming from different digital and smart appliances. So we need to understand, have a system that collects data in a format that is easy to analyze, also easy to understand, and it can potentially be accessible from other users. And so we definitely see opportunities, for example, in having like a real-time platform. So as we've seen in other some cases in the United States, so having real access to online platforms and understand in a visual way and efficient and engaging way the potential of the different measures and technologies.
Great, thank you, Angeliki. Now we have a question here about, and we'll start with, so this is potentially for both of you, but we'll start with you in this case, Angeliki, about whether there has been any consideration of setting up a market mechanism which would allow aggregators or energy efficiency service companies to potentially provide efficiency services and efficiency projects to you on a pay-for-performance basis. So rather than the DNO going out there and rolling out LEDs, to set up a market whereby service providers would provide energy efficiency measures to you as a DNO as part of a market-based mechanism. Angeliki, has there been any consideration about that?
Thank you. Thanks for the question. It's a great question, and this is one of the questions that we had in mind when we were designing this project. We were setting up Firefly. So at this stage, we are not there yet, but this is something that we definitely need to consider in the future, and it will form our position as a DNO as to what is the best way to deliver energy efficiency. But I think the important thing is first to build a solid CBA, to understand better the costs and benefits of doing energy efficiency, because everybody agrees that it's great technology, let's do it, but then we need to understand what is the best way to deploy. Should it be in combination with other technologies? Should it be through, I don't know, I like flexibility tenders, so the tenders that we have already as the BAU, or should we encourage third parties to participate? Should we offer more longer-term contracts, for example? All of these open questions at the moment, and we're definitely going to discuss and understand them better in the next year.
Right, thanks, Angeliki. Charlie, did you want to add anything to that?
Yep, I think we can. I think Angeliki's Firefly project is a great example of how we're moving this sort of forwards. I also think that the social constraint managed zones that I touched on, that would be the current route to market for this. So especially in an aggregator-led model, there's no reason why you can't compete within the current constraint managed zones, which all of the DNOs have at the moment, and that are operational through a platform called Piclo. You can see where those are available. There's no reason why you couldn't bid in domestic demand side response and energy efficiency to compete with things like your battery storage and your commercial demand side response at the moment in those markets. The social constraint managed zones in particular are set up for this sort of thing because they're a little bit simpler. They've got the different pricing mechanisms, so they're not based on availability and utilization. They might have a pure availability option, so that they're better set up for things like energy efficiency. Okay, and that social CMZ project can be found by Googling Community Flex, or by visiting the SAVE project website, which I mentioned earlier, save-project.co.uk.
Great, thanks, Charlie. We have some more questions coming in. Before we go to those, I'll just ask if both of you are okay to maybe stay for 10 to 15 minutes extra, so we can try to get through as many of the questions that we have. Is that okay for both of you?
I can probably do 5.
5, okay.
Yeah.
Okay. Okay, so what we'll do now, I'll merge two questions together. So this is about, I think, some regulatory aspects, and the question really is around what regulatory changes would be needed to integrate energy efficiency at scale into network companies' investments. And do you see this as a chicken and egg situation, in that you really need to have policy action from a national government level to actually allow energy efficiency to be incorporated at scale into your investments? I'll start with you, Charlie, on this one.
Absolutely. Okay. I think very good question. I think there's a few aspects I'd give to this one. So first of all, I think DNOs have an important role to play, but I think we are just a slice in the pie. Likewise, I think government have got a very important role to play, but I think that they're also just a slice of the pie. I think energy efficiency is so far reaching in its benefits, not just through the electricity system. So something you do at distribution level is going to benefit at transmission level. It's also going to benefit potentially at supply and generation level in the sort of trading markets. So that needs to be considered, each one of those steps of change. It will have benefits and impacts across different vectors, if you like. So it will have impacts across gas. It might also have impacts on water. Water is actually one of our biggest consumers within the UK. So if you can get water efficiency out there, you also get energy efficiency and electricity efficiency as a byproduct. So how do we need to be considering that? Okay, government is the obvious one. Okay, carbon savings, that sort of thing, that needs to be recognised. The kind of social cost element of things, as we touched upon within our social constraint managed zones, we're starting to delve into already, but how do you quantify those sort of social aspects are key questions that we need to be lobbying with government, we need to be pushing through, because actually these things only start to make sense when you do account for that entire system benefit, when you do account for the carbon benefits, and when you do account for the fuel poverty engagement that you're going to get out of it, and then it becomes a no-brainer. But any one of those in isolation, you're going to struggle to build a commercial business case for this. So that full integration is absolutely key. I also think there's a massive opportunity, again, alongside heat and transport. With the future of heat and transport, we're probably going to be doing visits to almost every home within the UK to install charging points or whatever the future heat system is. As a result, I've already hinted that the main costs of energy efficiency throughout the SAVE project with things like consumer engagement is not the actual cost of the technology. You've got a huge opportunity for consumer engagement there and visiting every home across the UK, okay? The technology is not the expensive bit here, it's the engaging the customers, and that's a huge opportunity for me. And the final one is something called optionality value. And that's the fact that there's a huge amount of uncertainty going into the future, okay? And if we're going to run flexibility markets at the moment, what we do is we calculate them 4 years ahead based on a simple net present value of deferring reinforcement. So if reinforcement is going to cost £1 million and the interest rate's at 4%, the value of flexibility is defined by what that 4% on £1 million is worth over 4 years. Okay, what that doesn't take into account and what the regulation at current misses is the fact that what happens if we forecasted that EVs are going to take off, and as a result we run a flexibility market to deal with this increased load of EVs, but in 4 years' time EVs haven't taken off and the government's policies changed and we decide to go with hydrogen instead. Okay, had we not done flexibility, had we reinforced the network under traditional means, you'd end up with a huge stranded asset, huge amounts of investment. It's like building an extra lane on a motorway and then it never gets used. Okay, that's not recognised as a benefit of flexibility at the moment, and we need to find an economic way of recognising that and building that into flexibility markets, and that needs to be recognised by Ofgem. Okay, so I think there's a few things: the stacking piece, the future potential of heat transport, what that does for energy efficiency, and the optionality piece.
Yes, thanks, Charlie. Very comprehensive answer there. Angelique, anything quickly to add to that before we go to maybe one final question?
I don't think I have much to add to this very comprehensive response. Yeah, I agree that we need to, first of all, understand the CBA, understand social benefits, and also understand the whole system benefits of energy efficiency. There is also another element we need to consider, which is how do we make sure that customers would benefit equally from energy efficiency? And for example, those that have already deployed energy efficiency, they have paid for these measures, and now they will be asked to pay again for to cover the cost for upgrades in other customer houses and stuff. So this is a very important topic that we need to understand around whole system benefits of energy efficiency and how they will be equally distributed across the customers.
Great, thanks, Angelique. And this will be the last question that we'll have for today's webinar, and it's about some of the technology that you rolled out to consumers to help them save energy as part of the trial. Charlie, you highlighted LEDs as obviously a very easy packaged, easy technology in which to roll out to get big benefits quickly. But are you actively considering any other technologies which can be rolled out to consumers to help them save energy and provide these energy efficiency resources to the grid other than LEDs? Charlie, we'll start with you again on this one.
Yeah, no worries. So I think there's a big behavioural piece in here. I think what you do, SAVE was very academic in its nature, in that you wanted to very much have defined control variables and defined dependent variables that independent variables, sorry, that you're gonna change up. Okay, what we would do in the real world is, of course, put things like nudge techniques alongside LED lighting, maybe put a price signal alongside that as well. So you're rolling out all of the things trialed and SAVE on top of each other. I do think that as price signals come into play, then the opportunities for a lot of different technologies become a lot more attractive. And that's where I think future projects are going to be looking at. So there's a project who I've been racking my brain to remember the name of, being run by Western Power Distribution. that is looking at sort of more smart home, more automated based technologies. Unfortunately, I can't remember its name off the top of my head, but if you do look at WPD's Western Power Distribution's innovation page, you'll see it on there. And they are looking at a lot more kind of forward-looking, automated-based approaches. And I think with price signals, that is probably the future that we'll start going down towards. I also think that coming back and playing an old record, that the potential here will increase vastly, and we'll look at a lot more technologies if a decision is made around future of heat, or what future of heat looks like, or if we start to see a lot of electric heating coming onto our network, because then that does open up a lot of benefits in terms of energy efficiency, loft insulation, solid wall insulation, all of those sort of classics that we as a DNO would start becoming quite interested in terms of reducing electricity demand as opposed to gas demand.
Thanks, Charlie. And Angeliki, any other thoughts to add about technologies beyond lighting that can be used for these projects?
Thank you. Yeah, as I said before, we are at the moment we are considering what is the best way to roll out energy efficiency. So based on these international programs, SCAN, so we've realized that most of the utilities are using energy efficiency in combination with other technologies, such as energy storage, and demand-side response. So if we are to roll out in a BAU, we need to be careful about the locations that we're going to have in mind, potentially complement this with our flexibility tenders. So last week we've also announced flexibility tenders in low voltage, which is a first for DNO, and this is something that there's going to be a lot of discussion in the near future. But yeah, I'm not in a position to share more information at this stage, but it's definitely going to be discussed under this project. So stay tuned for more information.
Angeliki. Thank you very much for your answers. Thank you also, Charlie, for your answers during the question and answer session today. And thank you, everybody who put forward questions. They were all very detailed. Unfortunately, we couldn't get through all of them, but hopefully the questions that were posed were interesting and enlightening to those on the line. We will close the webinar there. Thank you again to Charlie and Angeliki for your time this afternoon. And thank you all very much for your interest. As I said, we will be posting the recording from today's webinar, including the slides after this meeting. So keep an eye out for those. And thank you very much, everybody, and have an enjoyable rest of the afternoon. Bye for now.